Right, so in this video, we are reviewing pH, which is something that we did in class today. And we're also talking about how pH can be balanced with water, or the fact that water has a balanced pH because of its concentrations of hydrogen and hydroxide, all right, which is our hydrogen and our OH groups. So pH is defined as the negative log of the hydrogen ion concentration. Now that sounds a little strange and it's a little bit math heavy, but it actually turns out that pH is simply written as the negative log of our H concentration. Remember that concentration is the amount of hydrogen that is in any given solution. If you have a solution that has water in it, there's always some amount of a hydrogen concentration. There's also always some amount of oxygen concentration with our hydroxyl groups. Our pH is simply measuring what that concentration actually is. So even though this looks complicated, it's actually not so bad. The nice thing is that this function here gives us a very, very simple way to think about our pH, all right? And that simple way is this. Every pH value we can translate into a specific hydrogen concentration. And we can do that by plugging it into this equation here, all right? Or really not even an equation, just a number. So in this case, we have 1 times 10 to the negative power of 4. So if our pH is 4, then our H plus concentration will be 1 times 10 to the power of negative 4. Now this holds true for every pH value. No matter what your pH value is, you can plug it into this setup in order to get the H plus concentration. For our pH of 12, our H plus concentration then is going to be 1 times 10 to the negative 12. All right? You're simply plugging that pH value into 1 times 10 to the negative pH value. Now, if you were to write out what this looks like, the number itself looks like 0.0001, and that's actually a molarity, okay? Now, here our base would be a lot of zeros and then a 1, and that's because we have 1 times 10 to the negative 12. Now our molarity is simply our measurement of concentration. Our molarity is telling us how many moles of this particular chemical are in our 1 liter solution, all right? So the molarity here is clearly a much bigger number than our molarity here. So that shows that this has a lot more H plus concentration, which means that it has a lower pH value. So this one here is going to be an acid. The 4 falls down here on our acidic part of our scale. On the other hand, we have 12, the pH of 12 is our base. And as you can see from the concentration, that's basic because there is a very, very small amount of H plus in this solution. Now, like I said, when you have a water solution, or where water is the base, you always have some H and some OH. So this equation down here is showing this dynamic equilibrium between water and then the 2 ions, your hydroxyl ion and your hydrogen ion, all right? So when this is in equilibrium and you have just pure water, you're going to have a balanced concentration, where you would have a concentration of our hydrogen of 1 times 10 to the negative 7. That's going to be the same as having a pH of 7, which is right here in the center of your scale. All right? So this is just some catch-up information to help you feel comfortable with pHs. Tomorrow in class, we're going to be using indicator strips in order to determine the pH of different substances. All right? And these are all going to be household chemical substances that you use in your daily life. So that's all for now. I hope that you have been able to learn something from this video. Remember that you need to write down at least 3 questions. These could be questions that you have or questions that you could quiz someone with after watching this video. And you're also going to write down a summary. Make sure you write those things down along with your notes.